Okay, hello. Yes, today I'm going to be taking you through the process of performing one sample t-test on SPSS. And as you can see, this is my SPSS environment that I'm sharing on my screen. And of course, here, as you can see, I'm having variables from with a total of okay, I'm trying to check the total number of observation for these particular variables, and we have a total of 1,674 observations. And therefore, basically what I want us to do, as you can see here, what we are having is, of course, we have three main variables, and these variables have been derived from a call center, and the call center recorded this data in terms of protocol types. And we have two protocol types. One is called PE protocol type, and another one, let me show you, PT. The other one is called PT. So between the two protocol types, we are required to of course, perform one sample t-test. And the first variable has been protocol types, as said earlier, and another variable is queue time. Another variable is service time. Now, queue time is the amount of time spent by a client on a call queue, waiting for their phone to be picked. And service time is the total number of time taken in terms of seconds, as you can see. In terms of seconds, the total number of time taken for a client to communicate with their call attendant, or after their phone call is picked, how much time will they take as they communicate with the call attendant. Now, I want to create my own mean and try to say that specific mean is equal to the real-time mean. As you can see, the real-time mean of all the service time, the service times in terms of seconds. So I can say that a mean time of 300 seconds is equal to the real mean time of the service time taken by a client while communicating to an attendant. And now I go ahead and perform a one sample t-test. When you are performing this test, you normally go to analyze, you go to compare means, and the second option under the category of compare means is one sample t-test. You click there, then you select your variable service time. I had already selected it. Now I want to, I deselected it. Now I want to reselect it so that you can see how it works. Now, after selecting your variable and entering it into the test variable, you can go to the options. The options here will give you the main thing here is the confidence interval percentage, which is by default 95%. That is the standard confidence interval percentage for statistics, which is equal to 0.05 significance level. Now, under your test value, here you input your mean, the estimated mean which you want to compare with the real service time mean to see whether they are equal or different. Now, I'm going to delete it and type again 300, or let's say I can change to of course 250 seconds. Now I proceed and click OK to obtain. Yes, I'm thinking that I need to. Yeah, I click OK to obtain my results, and the results window has disappeared. So I need to stop sharing this window and start sharing another window. And the window I should be sharing is the results window. Which is this one. And let me expand it so that you can see it clearly. So as you can see, after obtaining the results, the first thing in the results is the one sample statistics. And the statistics will always provide you with the total number of observations, total number of participants for that variable, which is N1674 or 1674. And the mean, which is 18.12 seconds. I'm sorry, and again, the standard deviation, which is 190.76, and of course the standard error. Again, you can see our main results here. The results give you the variable name, service time, and the T statistics, the one sample T statistic, which is negative 14.988, and the degrees of freedom, which is 1673, and the significance level, or the p-value of 0.0, 0. So, and a mean difference of negative 69.879, and of course the confidence intervals. Now, when you check, or whatever you are required to report whenever you are conducting a one sample t-test is first of all the mean and the standard deviation of that particular test, which is 180.12 and 190.76. Again, you should report the t-statistic, the DF, and the DF is always the degrees of freedom, and the significance level must also be reported. So again, you must have to make a conclusion whether the two means, the real mean 180.12 and the estimated mean 250, the one we entered into the test value, are the same. Now, depending on our results here, we see that the t statistic is significant, and therefore we say that the null hypothesis, that is, there is no difference between the real mean and the estimated service time mean, should be rejected depending on this significance value, because this p-value tells us that it is lower than 0.05, as you can see. So when it is lower than 0.05, you can always reject the null hypothesis and go for the alternative hypothesis that states that there is a difference between the estimated or our test value 250 and the real mean service time, which is 180. Now, so generally, you could be wanting to make a recommendation to the call center, because we of course, this negative mean difference says that the real mean time is lower than the estimated mean time. Now, this means that the service time a customer takes in the service time, I mean the service time taken, the number of seconds taken under service by a client is a bit lower than the service time expected, which is 250. That is around over just slightly over 4 minutes. So they may need to, the call center may need to increase their service time to ensure that they comprehensively cover all the concerns of their clients. They should not rush them. This is the conclusion you can make with or the implication or the decision you can make with this test. So generally, a one sample t-test will always be used to test whether, of course, whether your estimated mean for a particular variable is matching the real mean for a collection of data sets on that variable. So I think with that said, I'm done and I thank you.